Hey guys, Mr. Fisher here. I'm gonna try to get through this in the 15 minutes allotted, but we went through most of the module with the exception of one question today. So hopefully, if you were there, you were paying attention. If not, you can kind of catch back up with me. But I didn't want to do anything repetitive. This is at the very end of lesson unit one, lesson five. This is that practice quiz. So I figured I'd walk you guys through it, and I'm gonna add this to today's lesson. To select all parallelograms that have a correct height labeled for the given base. And remember, if it's the base, the height has to be 90 degrees off of the base. So in section A, obviously there's the base. It's all 90 degrees off of it. So A would definitely work. B, here's the base. They're saying this is our slant height. That would be incorrect. They would have to have a dotted line somewhere along going straight up vertical from that base. It has to spawn off the base in order to be its height. Okay? Here's the base here, and it extended it. The height could be this line, which is good, or it could be this line, which is also good. So any line. Remember, there's an unlimited amount of lines that you can put for the height. It can go all the way across just as long as it's going from base to base. It's touching this line all the way down to that line. And then D, our base is over here. Would this cut it as the height? Yeah, because this height, and again, they're trying to show you if I move this into this spot, it would fit exactly and turn into a giant rectangle. So here's my base. Even though we don't see the 90 there, they're telling us there's a 90-degree angle there. So it would. So problems A, problem C, and problem D would be good. Problem B does not work because there's no 90-degree angle. They'd have to have a vertical line spawning off that base perpendicular to it. Okay, so you would have selected A, C, and D had that been a test question. Okay, question 2. The side labeled B, so here's our base, has been chosen as the base for this parallelogram. We need to draw a line segment. So, and again, I don't have the line segment there, but if you would have had, oops, let me go to my Ladybug here. So launch the app. So here's my Ladybug. I could have drawn a line anywhere along this parallelogram, just as long as I have a 90-degree angle perpendicular to the base. So I'm just going to do an easy one that's pretty common. So I'm going to draw, and you don't have a option to do that on your computer. You will on test day though, but this would work. So would this would work. So would this. Any perpendicular, it has to be perpendicular to that base or to this base. That works. Okay, you can never use those slant heights, not when it's not perpendicular to the base. All right, getting back into it. Question 3. Find the area of each parallelogram. Okay, so again, I'm going to add some numbers. So just to show you, this is 1, 2, 3, 4. This is 1, 2. So the height would be 2. The base would be 4. So if I go into Ladybug again, launch the app, I would have had a base of 2, or a height of 2, I'm sorry, and a base of 4. So that was pretty easy for most of you. I think you would probably have A is equal to base times height, 4 times 2, and that would be 8. 4 times 2 would be 8. Okay? Secondary problem. When I come back over to here, this one's a little more complex, but remember, we could cut this off, decompose it, rearrange it, or I can use the algorithm, the formula. So I have 1 square, 2 squares, 3 squares, 4 squares, 5 squares wide, by 1 square, 2 squares tall. So 5 by 2. And again, if you went over to the Ladybug, here is my shape. This would now be 5 squares wide. We measured that out by counting the blocks, and it's 2 squares tall. So our vertical height would be 2. A is equal to base times height, 5 times 2, 10. So we should have had 10 for that second one. Go back to it. This guy is at an angle. It's a little bit strange, but again, we could cut this into 2 triangles, glue the triangles together, or I can just say, well, let's try to make this the base down here. So the base. So it's 1, 2. So it's 2 this way. This is my other base. Well, how far is it in squares from one base to the other? 1, 2, 3, 4. So then 4 times 2. Go back to the visual here just to show you. So if I would have had that, I would have had 2. And then for my vertical, it would have been perpendicular to it. This would have been 4. So 4 times 2 would have then been 8. Okay, so make sure you pay attention to question C on that. That third one, that's a little tricky. So this one here. So it would have been 2 2 times 4 is 8. All right, question 4. This is where you really, really need to know your stuff, but it's not difficult. You just have to read. It says if the side of the unit is 6 units long, so the side that is 6 units long, here's that side that's 6 units long, that's the base. What is the corresponding height? So I know there's 2 90-degree angles in here. There's 2 right angles, but which one is perpendicular to the 6-unit base? So if this is my base, the 90 has to be touching that. It would be here. So it would be 4. So I would click 4. Okay, it would not be this one. This one would be, the base would be 5. So the 4.8 would correspond to that base. It wouldn't make any sense to do it with this because it would have been a slant height. Question 5. Find the area of each parallelogram. This one's pretty straightforward. Here's my base, 9. Here's my height, 4. 9 times 4, 36. Remember, this triangle could fit right there. This guy, they're giving us a little additional information, but I have a 5, I have a 4, and I have a 5. I would want to make sure I use this 5, because I know there's 2 of them, but this base is perpendicular to this height. So 5 times 4, 20. Okay? Now, how am I supposed to find the area if I don't have any numbers? Well, in this case, this is the formula again. So I'm just taking my base. So you would have B. So on a test, you would literally put B times sign H. Base times the perpendicular height. Okay? So 36, 20, B times H. Question 6. Do you agree with each of these statements? A parallelogram has 6 sides. That would be false. It has 4 sides. Opposite sides of a parallelogram are parallel. That's always true, or it would not be a parallelogram. A parallelogram can have 1 pair or 2 pairs of parallel sides. That's also true. So actually, I'm sorry, that's not true. If it only had 1 pair of parallel sides, it would not be a parallelogram. So that would end up being like a trapezoid. So a parallelogram can have 1 pair. That's not true. 2 pairs, yes, but not 1 pair. All sides of the parallelogram have the same length. That would not be true. It could be, but you could also have a parallelogram that had like 2 sides that were 6 and 2 sides that were 4. So that would not be true. Number 5, all angles of a parallelogram have the same measure. All angles. And again, that doesn't have to be true either. You can have 2 obtuse angles and 2 acute. You can have 4 90s. You can have a lot of different variations. You can have, just as long as the angle measures were congruent, you should be good to go there. All right, this one was pretty interesting. I kind of like this one. It says a square has an area of 1 square meter, and it's decomposed into 9 identical small squares. Each small square is then decomposed into 2 identical triangles. So what is the area in square meters of 6 triangles? If you get stuck, draw a diagram. So I did. All right, so we're looking for how many would 6 triangles be? Well, if I use this, here's our diagram. Okay, so I'll zoom in a little bit. We are only looking for, I know this is 1 square meter, correct? 1 square meter. So we're looking for 1, 2, 3, 4, 5, 6 triangles. So if I were to shade that in, so imagine if this was all shaded in, just these triangles were shaded in. Well, how much of a 1 meter square were just those 6 triangles? Well, if you think about it, take all the lines away except for the green, it would be 1/3 of a meter squared. So you only have 1/3 of that entire area shaded. Okay, so that would be an answer to number 7. That's a visual of what's going on. You dissected it, broke it up into 9 cubes, or 9 little squares, I'm sorry. Cut each of those squares in half using triangles. And then we only needed 6 of those. That would be 1/3. 1/3 of the meter squared. How many triangles are needed to compose a region that is 1.5 square meters? So remember, if we go back to our diagram, how many triangles would we need to make just 1 meter? Well, I know this row has 6, correct? Well, if that's 1/3, 2/3 would then be 12. 3/3, which is a whole, would give us 18. But I need 1.5. Well, 1.5 would then be down here. So you could go straight across. I kind of did it this way so you can visually see the half. But up here, there's 6. This second row, there's 12. Third row, there would be 18. This row, and all these together is 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So 9 out of the 18 would be the half. And in this case, we have 9 plus 18. 9 plus 18, you would need 27 triangles to make 1.5 square meters. That's literally a visual of what's going on. Okay. I would not expect every kid in the class to hit this one because this one is pretty advanced, but these are the type of state questions you guys are going to see, and these are I learned this along the road somewhere, guys. It's not like I went to some advanced math class to learn sixth grade geometry. So it takes practice, it takes studying, it takes watching videos, it takes doing practice problems out of the textbook, getting help from tutors, other friends. Try to give your parents a break because they had a stressful enough week as it was. But if you need mom and dad, you can always ask them. Okay. And then that's pretty much it in a nutshell, guys. If you have other questions, I did have tutoring today, guys. I only had 2 students show up. So one student was from first period and one student was for first block. The other student was from third block. So if you're struggling, you have to come see me Thursday morning, 8:30 to 9 o'clock every Thursday. All right. See you guys soon. Hopefully that helps. And then this will be on, in order to get to this, remember you click on pages. To navigate away from this, you would click on pages. And then you click on view pages for those of you guys that forgot how to get to it. Okay, I understand it's in the video, but just in case like somebody had to track it down for you. And it's going to be, obviously it would be in today's lesson, like yesterday's was the 25th. Here's your video from yesterday. So that'll be on this video will be on the 26th. Have a good night, guys. And please study hard. Make sure you guys are ready for your little practice quiz tomorrow. It's a pretty easy quiz, but it'll be 10 questions. Double check that you have all your edge elastics in Monday through Friday. It's only 2 questions per day. And then you have the modules, which I worked through with you the last 2 days. You did a few on your own throughout the week. All right, good night, guys.